Hello, I'm going to demonstrate how to run a hierarchical regression analysis in SPSS and JASP. And we are going to use the data file D2 for this demonstration. In order to learn hierarchical regression, you have to have a good understanding of regression analysis. Hierarchical regression analysis is just an extension of regression analysis. So please first watch my video on regression analysis. In hierarchical regression, the independent variables are entered into the regression equation in a series of steps or blocks. Instead of sending all your variables in one block, you have more than one block. So you send your variables in more than one step, usually based on a theoretical reason. The purpose of this approach is to determine the unique contribution of each block of variables. This means that you can examine the unique effect of a variable or group of variables over and above the effects of the variables entered in the previous block or in the previous step. It will become easier when I demonstrate. So in SPSS, go to Analyze, Regression, and Linear. You see that this part is related to blocks. So this is where you can have more than one block. Happiness is our dependent variable, so I send it to the dependent variable box. Now, I want to enter our independent variables, but this time, instead of sending all of my independent variables in one block or one set, I want to send them in two blocks. In the first block, I send only family happiness. So one variable is your first block. You can send more than one variable in your first block or first step. But for this demonstration, I just send one variable. And then here, click on Next and send your second block of variables. For this demonstration, we are going to send 3 variables to our second block. You can check the previous block. So you have family happiness in your first block. And in your second block, you have 3 variables: social support, quality of life, extroversion. This is just a practice data set. It's not a real data set. So we cannot learn anything based on the results. We are just demonstrating how to run a hierarchical regression analysis. Go to statistics and take confidence intervals and collinearity diagnostics. Also, we need to look at R-squared change continuum. Now we can click OK and get the results. This table is presenting the results of 2 regression analyses. The first one, so happiness is your outcome and family happiness is your predictor. So this is your first block, your first regression here. And the second one includes family happiness, social support, extroversion, and quality of life. So your first regression has only one predictor, your first block of predictors. In this case, we only have one predictor. And your second includes all the variables you entered in all of your blocks. We entered 1 variable in our first block and 3 variables in our second block. All of them are included in your second regression. So SPSS is reporting 2 regression analysis. In your first regression, where you have only family happiness, the R-square is 40%. So 40% of the variance in happiness is explained by your first block. In this case, it's only family happiness. It's a large amount of variance explained by a single variable. And the second model, including 4 predictors, explains about 70% of the variance. In hierarchical regression analysis, R-squared change also needs to be reported. Now, when you added social support, extroversion, quality of life, the R-squared increased to 0.69. So R-squared change is about 30%, right? So this is just if you subtract this value from this value, you get this. So it's about 30% your R-squared change. And this amount of change is significant. Then again, you have the ANOVA table for two regression analysis. In the first one, there's only family happiness. And so your F is 85.001, which is significant. And your second regression includes all of your predictors, 4 predictors, and the F value is 70.9, which is significant. And these are coefficients, regression coefficients related to your predictors. In your first regression, family happiness was a significant predictor of happiness. And you can see that the unstandardized regression coefficient was 0.75. The standardized coefficient was 0.63. And this is the confidence interval, which does not include 0. So you have a significant predictor here. Family happiness alone is explaining 40% of the variance in happiness. So it's a very good predictor of happiness. Then you have your second, the results of your second regression analysis. And you have 4 predictors in your second regression analysis: family happiness, social support, quality of life, and extroversion. Now, firstly, you can say that adding these 3 variables increased the R-squared value by 30%. It increased it from 0.4 to 0.69. So it's about 30% increase in R-squared. So together, these 3 variables are contributing 30% more variance. But now we want to see each of the predictors in the second regression analysis, which one is a better predictor, which one is significant, which one is not significant. Unstandardized regression coefficients are reported here, and then you have standardized regression coefficients. As you can see, the strongest predictor is extroversion because it has the greatest standardized coefficient in the second regression analysis, and then family happiness. Social support and quality of life, the contribution is smaller, relatively smaller. And when you look at p-values, you see that family happiness is significant, extroversion is significant, but social support and quality of life are not significant predictors. So we can say that extroversion predicts happiness over and above family happiness. But social support and quality of life cannot predict happiness over and above family happiness. So that's exactly why we did a hierarchical regression. We wanted to know if our second block, social support, quality of life, and extroversion, can they predict happiness over and above family happiness? Can they contribute unique variance over and above the contribution of family happiness? And in this case, we can say that extroversion can predict happiness after controlling for family happiness. But social support and quality of life cannot predict happiness after controlling for family happiness. So basically, the variable that you enter in your first block, that's the variable or the group of variables that you are controlling for. And then you want to know that after controlling for your first block of variables, your second block of variables, can they predict your outcome or not? So how to report this? Again, please check my video on regression analysis and how to report it, because basically it's hierarchical regression is just reporting two regression analysis. So it's not very different in terms of reporting. So please see that video. This is one way to report your hierarchical regression, the hierarchical regression that we just performed. A two-step hierarchical multiple regression was conducted with happiness as the dependent variable. You have to tell your readers which variables were entered in the first step and which variables entered in the second step. And if you have a third step, you have to tell your readers which variables were entered in the third step, and so forth. The results showed that in the first step, so here you are reporting the results of your first regression analysis. Family happiness contributed significantly to the regression model. Your F value, significance level, and degrees of freedom for your first regression. And this is basically your R-square value that you're reporting here. Then you talk about your second step, adding the three predictors to the regression model in the second step. You report your R-square change, which was about 30%. And then you report your second regression model, degrees of freedom, F value, and P value. Then you mention that whereas extroversion was a significant predictor over and above family happiness, social support and quality of life did not contribute significantly over and above family happiness. And then you report the R-square of your second regression, which is about 70%. And finally, you need a table where you report your regression coefficients. This part of the table are reporting regression coefficients. And this part is reporting R-square and R-square change for step 1 and step 2, for the first regression and the second regression, including p-values. So this is one way to report your hierarchical regressions. Now let's do it in JASP. In JASP, go to regression, linear regression. Happiness goes to dependent variable box. And in JASP, you send all of your predictors together to this box, covariates. So you send all of them together, the 4 variables together. But when you click on model, you see that in this box, you see all of your variables. And here, click on the variable or variables that is related to your first block. We have only one variable in our first block, family happiness. So I tick this variable here. Now you have you are running a hierarchical regression. Your first block includes family happiness. Your second block includes the other 3 variables. And here you can click on statistics to get confidence intervals, R-squared change, and collinearity diagnostics.